This story explains techniques for improving the adaptiveness and resilience of logistical networks. Lisa is a supply chain manager for a car manufacturer. She negotiates service level agreements with suppliers, obtains information about the next year's product lines from Paul, the chief product line engineer, and relies on sales data provided by Sam, who manages the relationships with car dealers. Once a month, Lisa discusses her software needs with Adam, who heads the software development department. Given the volume of cars that are produced every month, Lisa must ensure that suppliers are able to react in a timely way to changes in demand. The more data is available on each item that flows through the network, the easier it is to compile statistics and to optimize the flow of resources and products. The Internet of Things is redefining the world of logistics. A logistical network, including all the items that flow through the network, can be represented in data structures in real time. With all this information, the MODA and MODE methodology is the perfect tool to pinpoint weaknesses and to design solutions that not only resolve specific incidents, but also address the underlying root causes. A failure to deliver by a supplier can easily lead to disruptions in production. Sometimes quality issues are detected far too late, when customers have run into a problem. It would help a lot if the critical dependencies in the network could be identified before they cause a disruption, and if more quality issues could be detected before cars actually leave the production line. MODA and MODE starts by visualizing the agents in the value cycle, followed by an analysis of the information that represents the flow of items in the network. The result is a blueprint for a set of automated systems with an architecture that reflects the structure of the network and the flows through the network. A typical input into the MODA and MODE analysis process is an event that triggers demand in the network, such as, Joe wants to buy a blue car. Adam uses this event as a starting point for analysis. He performs an object-oriented analysis of the event. This leads to a structure of objects that need to be represented in the software that orchestrates activities in the network. Adam then generalizes the structure of concrete objects into a corresponding structure of categories that express the generic scenario of a prospect wanting to buy a car from a particular product line. Adam knows that concrete events of this kind are recorded by the sales team. Next, Adam shows his results to Paul. Paul analyzes the structure of categories in terms of variability and the rate of change over time. The order process is different for each country, and a new order process needs to be defined each time the company enters a new market. Quantity and order status are examples of properties related to an order, and each new order process entails a definition of new properties. VW Golf is a product line that undergoes changes every year. Color is an example of a property related to the VW Golf product line. Each new edition of the VW Golf product line entails a definition of new properties. Paul and Adam conclude that partner is the only element that is unlikely to undergo changes at least once a year. This means that Adam can implement a customer relationship management system without needing to worry about a potential software maintenance nightmare. Paul proceeds with further analysis of the variables uncovered by the initial analysis, and defines an abstract structure of the categories which are stable. The instances of these categories are the variables in the original analysis model. Based on these results, Paul and his team can develop product line configuration software for Lisa and other domain experts. The solution enables Lisa and her colleagues to address all events that require reconfiguration of some part of the logistical network. The overall result is an optimized network in which human domain expertise is employed in real time alongside intelligent software systems to orchestrate activities in the network based on the internal and external events that relate to flows in the network. The MODA and MODE approach leads to clear boundaries between domains of expertise. The digital artifacts that flow between domain experts represent the flow of items on the shop floor and associated quality metrics. In particular, domain experts are immediately made aware of events that relate to changes in demand or events that signal violations of service level agreements. the business can react to change more quickly. And since the entire network is available as a formal model that can be processed by software tools, it can be subjected to analysis of potential failure points. Appropriate measures can be taken to improve resilience via the introduction of additional levels of redundancy in critical areas of the network. To learn more about S23M logistics consulting or the MODA and MODE methodology, visit www.s23m.com.